with online marketing only. And so with hyperlocal marketing, we with hyperlocal marketing lets you sort of target prospective customers which are around the property at that particular time. So it is very real time. It is very hyperlocal marketing, so hyperlocal in a sense, and it is much more effective than just the walk-ins would be. So then what we are going to do is we are going to tackle location-based marketing. We are going to tackle the e-commerce uh, zone and then the brick and mortar stores specifically in our example, right? And now the concept here is you have a vehicle driving by which has an app, let's say, and this app is sort of giving location. And if you can see here, there is a store. It's called HackNC. I've taken an example in Berlin, but when the car walks past, or rather, a car drives past the store, the user will get a notification in their phone which says, "Hey, there's a store 200 meters away from you, and there is an offer there. Why don't you check it out?" So that is the kind of ad tech we're dealing with here. We are using the location of the stores, the location of the user of this discount coupon app, like something like Honey or something like that. And so we're using that to give them specific offers on specific stores that they might pass through and physically pass through. So the concepts that we're going to use in this are one is geofences. And so geofences is a virtual fence. In that sense, a virtual fence that we draw around stores. And we store it to our server, which is the here location services server. And with this, what we can do is later on, we can ping the server to say, "Hey, I'm here. Am I near any of your fences? Am I near any of your fences? Or am I inside any of your fences? Have I left any of your fences?" And so these fences are nothing but polygons that we draw around a certain building, around a certain property, around a certain area that we need to focus on. And so once we have those geofences, like I said, we store them into the server. Then what we do is you take your app, the mobile app, and the mobile app is constantly sending its Latin long to basically the mobile app counts as the IoT device here. And it could, like I said, it could be the mobile phone itself, it could be a device, the tracking device in cabs and such. What it is doing is constantly pinging the server with its latitude and longitude. When it does that, the server will invoke another Lambda function. And now this Lambda function has access to the geofences server. So what it does is this Lambda function will ask the here location services server that, "Hey, am I in your geofence? Am I near your geofence? Where am I?" Right? So it will constantly ping the server. And then this is the whole architecture, the way it would work. So your phone is sending or their phone is sending the latitude and longitude to the AWS IoT gateway. The AWS IoT gateway sends it to or pushes it to the server, which checks if we are in the any of the geofences or not through the Lambda function, and then gives you a notification back that says, "Hey, I think you are near a certain store," and then prints out or like pops up the ad for the store. So let's take a look. So what I have here is a WKT file, and a WKT is the full form. The full form is well-known text, but it is one of the formats that is used to define geofences. So one is shape files, and if you're not familiar with these terms, don't worry. I have this workshop in a GitHub repository somewhere, so I will send you the link in the chat later. So, like I said, yes, uh, well-known text is a format to define shape files, to define polygons, or like here you can see, you have the name of the store, and then you have the polygon that represents the outline of the store. And it is it is stored in longitude first and then latitude. So it stores it as the x coordinate and y coordinate of that particular location. And once you have that stored, you can basically make a call to the Fleet Telematics API upload. So I'm going to show you where that is. So you go to developer.here.com, and in that you find the Fleet Telematics APIs. Within that, you find the custom location API. So geofencing and custom location are related. With geofencing, with custom locations, you can upload these locations. You can upload these fences, and then with geofencing, you can retrieve them. So we go to the custom locations API, and we click on layers upload. So you can see fleet.ls.yourapi.com/2/upload. And then you can upload this file with the API key, and you can give it a name, the layer ID, and then that's it, right? Now, when I said API key, you need to get your API key by signing up to this platform. So click on sign up or click on login, as I already have a login ID. But when you click on login, it will take you to a page where you can have an account for free. So it's the freemium layer of the account. You don't really need to enter a credit card. So just go ahead and create an account. And once you have that account, you'll be able to create this JavaScript API key, and yeah, REST API keys, bunch of other Android, iOS keys. But right now, you can just create one REST API key or a JavaScript API key. And once you have that, use this key to upload this layer. Now, when you upload a layer with a specific key, you can only retrieve points in that layer, or you can only call that layer through this key. So all your geofences are strictly tied to your key. And having said that, this is because you use your own data. Your data is not used by anyone else. So any layers created by you are not used by anyone else. So which is why it's necessary that you use excuse me. Yeah, so it's necessary that you use the same API key to upload the layers and the same API key to try to retrieve where you are in respect to those fences, right? So once you upload this, you can also see them here. So it's enterprise.here.com. And now you use this app ID and you use this key. I am going to type this in. So once you see this, you'll see a page with different layers that you have added. These are again all my layers that I've been testing over time. But if you see, I'm specifically interested in this retail layer that I added. So the one that we saw before was the layer called retail, and it has polygons of these stores. So if you can see Heckmanhofer, you can see Galeria Kaufhof, you can see Zara. And so what I've basically done is taken the outlines of these stores and stored them as geofences. And now I'm going to have to write a code to sort of retrieve, to send my latitude and longitude, and then see if it is near any of these, right? All with me. I'm going to check the messages if there are any, anything in the chat. So far, so good. Perfect. So there we go. So once you're here, once you've created those, and again, I'm going to share the link in the chat after this, so you can follow the steps one by one again if this is going too fast, too slow, blah, blah, blah. So now what we're going to do is we are going to deal with the AWS IoT part of it. We are going to configure our device, our mobile phone, as an IoT device with the AWS IoT server. Now, for this specific workshop, I have created a dummy route. I don't really have a car running around right now giving me locations as it is 7 a.m. on a Sunday. But normally, also for workshops, you would not use directly the location. I have a simulated file. I have a file of a simulated route, and I'm going to put that in as my IoT device. So what you can do is go to the Amazon console. So awsamazon.com/console. And then I think we have it here somewhere. Uh, there you go. So you click on onboarding things. It will tell you to onboard a device. Let's do that. Now I am using Python and OS X. So let me click that. If you can see, your installation will, your public connection will be on the port 888 and so we need to use that later. And let's give it a name, NC thing. It could be anything. And then you need to download this kit, because this kit is going to give you all these policies. It is going to give you all. Let's save it here. Okay. So once you do this, you need to unzip this package and start this. What this is going to do is create a test file for you, and then also create something called the root CA certificate. So what you need from this is, sorry, the primary certificate key. Let me show you this. So if you can see my screen right now, what you need is the private key, the public key, the certificate, and then there is something called a root CA certificate that you will get from this, right? And you need these three. You need these three to connect to your device, or to connect your device to the AWS IoT server. Once done, you can just go to your things and see your things. And once you do that, you can then click on interact. And this is the URL that you're interested in. So this URL is your connection to your device. And you can try, or you can test by sending your whatever you want, are going to send through the IoT with this. So let's test this. Let me do this, and I'm going to show you something. We'll do it again sometime later, but so what I'm doing is I'm running my dummy location file and just sending latitude and longitude. And now this is what you should see here. Perfect. So this is what you see here. You'll see that on the topic IoT, I'm sending a latitude and longitude, and you can see my server working well. So it's receiving anything I'm sending. So that is done. I'm going to shut this down again. Perfect. Now, once we have that, we onboarded the vehicle or the IoT device. We use the policy. Now we are going to concentrate on the data publisher I wrote. So right now I just sent a few things to the server, right? And the way I did it is I used a data publisher using Python and Flask MQTT server. So with this, I am able to sort of read, first of all, read a CSV file, and then connect to my IoT device, the server, I mean IoT core server, and then send latitude and longitude onto that server. So what I've done is, if you can see the code right now, I am using on connect. If the connection is right, send a message. With this, I'm initiating it with this latitude and longitude. And then I'm connecting. So this is the URL that I was talking about. Right now, it's blank because, uh, well, you show that so that you not do not use my credentials. But yeah, that's really the to show you the format of these things. So the format is always a key. Then there is dash ATS, IoT, your region, whatever region you chose to create an account from, and then Amazon.com, AWS.com. So, like I said, if you go to things, your thing, and click on interact, you'll see this is the URL that you need to enter here. Then the port 8883 that we saw, which was the AWS port, the port that they'd given us to sort of communicate with the device. And the client ID could be really anything, any ID that you choose to call your IoT thing. You have the root CA certificate that we downloaded earlier, also the certificate and private key. And once you have that, basically I'm looping in this AWS reader and then checking. Oh, somehow I turn on my Siri. Sorry. So I'm checking my latitude and longitude, and then sending it or publishing it to the IoT topic. So if you saw earlier, we subscribed to an IoT topic to see if everything was fine. Right now, what we're doing is we are publishing to this topic called IoT. Again, you can name it whatever you want, and then sending the message, right? Otherwise, we just say, I'm waiting for connection, and then move on. So once you have the data publisher set, what you have really is you have your mobile phone set, which is sending its latitude and longitude to the IoT server. Next, we need to set up a Lambda to which pulls these latitude and longitude, and then checks from the here server, the Geofences server, whether I am near any of your devices. So let's go there. Let's go to Amazon.com serverless. So let me sign in. Not this account, I guess. Okay. So what we're going to do here is create a serverless application repository. Click on that, and then you click on available applications and type here. Once you do that, you'll see that here already has a bunch of different lambdas published already. And they're not only lambdas, but they also come with the REST API, the endpoint. And so you can just select one of these and work with those to create your own lambda. So I'm going to select the geocode, but because that is the closest to the geofencing API. And what we are really trying to do is if you go to the fleet telematics documentation again and go to geofencing, what we're trying to do is we're trying to do this. We are, sorry, this is, yeah. We are trying to take the latitude and longitude that we have and ping this server to check my proximity to the layer ID. And if you remember, our layer ID was retail. And so that was the layer of geofences that we've uploaded. So again, layer name of the geofences uploaded. And then I send in my latitude and longitude to ping, and then it gives me a response that, hey, it will probably give me something like this. So if I am near any specific polygon, or if I am near specific geofence, it should give me the attributes, the name of the place, and the geometry and the distance. How far am I? And so what we're going to do is, of course, we can call this API directly, but then you would be sending your API key there and which someone could use. So instead, we're going to create an Lambda function to do the same. And so now in the Lambda function, you just call it geofence proximity, let's say. And then again, for the API key, you use the same API key that you used for uploading these geofences. So again, you go to projects, you click on whichever API key you were using. I was using this one and I will enter it here and click on deploy. And like most of it, I could say 50% of your work is literally done here. While this gets created, we are going to check something. Okay, perfect. So once you create this Lambda function, you'll see that the function comes with the function itself and then also the API gateway. So we've already done that for you. Now, if you remember, this specific function was for the geocoding endpoint, right? And we need to change it to make it available for the geofencing endpoint. So what we're going to do is we are going to click on the developer page and search for the geofencing API. And then we're going to click on check if the asset is in the polygon or not, in the geofences or not. And basically we need to recreate this there. So you copy this and here, let me hope the size is right. Okay, so what we did was we replaced whatever geofencing call was. So I think I still need to. So you go to my Lambda functions, and I think I selected the wrong one. So what I wanted to do was the geofence proximity function, right? And now if you check this, so here it says search.hereapi.com. So basically it is for geofencing or geocoding. I'm sorry. Well, now we're going to change it to work for geofencing, right? And so we are going to copy this part of the URL and change this. So let's do this. So now what we have is https fleetls hereapi.com/2. And then we're going to keep this open because not only does this have the search proximity function, but it also has other functions like, hey, can you display this specific geofence? Can you do something else? So we're going to keep it a little open. We're going to keep it only until here. And then take everything else as the resource path. So we don't really need this constant here. And once you're done, just click on save and click on deploy. Now we need to make one more change, which is the API gateway. So you go to the API gateway and we just want a blank API right now. We don't want all of this, which is associated with the geocoding API. So we delete this, delete resource, and then just create a new resource, which is called resource path, the same variable that we used for in the code in the function. Right? And we're going to say plus because we're going to enter more things there. Create resource. and select the function. So it was geofencing proximity and save. And now it creates this method called any, but I don't want this method. I want the specific get method for it. So I am going to create another method. So create method and select get. Click on the tick mark, the yes, whatever. And again, select your Lambda function that you're making this for. So which was the geofencing proximity function. And click on save. Once you do that, you can deploy this function. So you can deploy this API on prod. And also you can test this. So let me click on this. So this is how it looks like. And now if you check the same example, let's say this is your resource path. So you want to search proximity, and then your layer ID, and let's say proximity is what you want. So my layer ID is retail, or all caps. It doesn't really matter actually. And I don't really, okay, I could do this. Okay, proximity is the latitude and longitude that you'll enter. Right now, I'm just going to use this one, but this one will say that this thing, the latitude and longitude is not near the layer. So let's do that. So it will give you there is nothing. And if you wanted to see how it would look like if there were a layer actually near this, I'm just going to pick up this one of the store's locations. So this is one of the store's locations that I already have. I'm just going to check this just to show you what it looks like. Okay, now test it. Proximity is this. Oh, and I need to give it a radius, which is 100, let's say 100 meters. So this is in meters. And then I'm going to check what else. I'm going to take this key attributes away. We don't really need this at this point. Okay. So now it says that it is near this store called Heckmanhofer because, of course, we gave the location of the store itself. So it's going to say it's near the store. And there you go. You have the geofencing Lambda endpoint set up. The Lambda function as the REST endpoint set up. So we are here. We set up the geofencing endpoint. Now we need to trigger, we need to add a trigger, and then we need to show the offers. That is what we need to do, right? So not yet, sorry. So let's go to the code. So what I have here is I'm going to close all of this up. Okay. What I have here is the publish function that I talked about. Now the publish function sends this location route, like the route that I created from this file. Normally you would send it from your mobile phone or like whatever app to or even a tracker device to the server. But I'm sending it here. And this is my Flask server. So I'm using a Flask server to run this application. This Flask server is literally doing the opposite. So it's reading, so it's subscribing to the IoT topic, and whatever it gets, it is storing it as lat and long, and it is giving to me on this on my host, local host, and slash get lat long. So that is what it's doing. It's just taking it and dumping it into another location, and is also running my application right here. And then now what it is doing is it is rendering this index.html file. So let's go there. Let's take a look at what index.html does. Now, what this does is it loads up a bunch of libraries that we need for the map to work. So you have the map core, map services, map UI, map events. And again, you'll get all of these on the website as well as in the code snippet I send you. And then we are just calling these different JS functions, which is the map.js, geofences, stores, icons, show card. So let's check it one by one. Okay. Yeah. So what the map.js does is with the map.js, we're trying to display the map. That's it. That's all we're trying to do here. So I'm using the key. Again, it's the same key that we used for uploading as well as creating the Lambda function. So it's the same key. And then it calls the default layers of the map. It gives it a point to focus on. So like to start with, it gives a latitude and longitude to center the map on. And then we just display it in the map container. This is the div ID I used in my HTML file. It calls for the vector map. It sets a zoom and it sets a position for it to focus on. Then it just loads up the default layers, map events, map behavior. And this is just to add some map style. And this is a custom map style, but you can also skip this part. It's fine. Once you have this, then you have the show car, right? And so what we're getting here is every 5 seconds, my server is sort of pulling data from the IoT topic and it wants to display it. So what we're doing is we are refreshing this and we're getting this from the get lat long that we remember we were throwing our lat long to. From there, we fetch that lat long and then we create a marker. Every time we get a new lat long, we are creating a marker and putting it on top of the map. So I'm going to run this and show you so that I'm not just speaking here. So let's run this. So I run the publisher first, and then I'm going to run the server. And as you see, it is running on 127 and the port localhost basically and the port 5000. So I'm going to open my port 5000. You can see there's a car here and it is moving on the road. Basically, that's what it is doing. It is moving on the road. And now what I'm doing is I'm basically refreshing every time I get a new location, I'm deleting the old point and creating a new one. Of course, there are better ways to do it with transition and stuff. We are not going to get into that right now. Now, once you do that, it is checking every time if it is in a fence or not. Now, if you see this is the same URL that we created for our Lambda function. So the API gateway that we got from here. So now if you see your stages, the production stage, this is the API that we use. So this is the URL that we used. And the layer ID retail, which was the geofence. I'm asking for key attributes. I'm asking for, or I'm saying that, hey, let me know if my point, which is the proximity here, is within 300 meters of any of the stores within the retail layer. So once I get this, I'm basically printing out, or I'm basically creating a marker with like a 20% off, blah, 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 at the store. So let's see this at work. So yeah, so it moved past this particular store. And because it was closed, it showed you this notification which says 20% off at HackNC Hofer, which is basically, that would be like a message that you would get on your mobile phone when you do this. So we are sending this and we are checking, basically, yes, we are getting all the stores that the location is near. And then we use the store name to sort of create a marker and then send the notification, send the offer. So that's all basically there is. Here I'm just displaying those geofences that I uploaded. So again, this is just for you for this workshop, but you can skip this part, sorry. And then that's it. That is all we are doing in this. So yeah, it came near the store and it basically said 20% off at the next store that we had a location to. So whenever the car would pass, or even if you're using, I mean, even if you're walking, it should do the trick. But whenever you change your location, it will check if the location is near in any of the fences, and that way the store owners would be able to send you ads that, hey, there's 20% off at Zara, why don't you come and check it out? So that's about it for this workshop. You can, if you want to ask any more questions, I'll be probably hanging out on Discord for some more time. Otherwise, you can contact us on at your dev or at your maps on GitHub, and then Twitch. You can watch us live on at your dev as well. I am also going to send you the link for this workshop if when you want to try it on your own. So it's on GitHub /sure maps. Again, don't worry, I'm going to send you the link to this. So you need to find DevRel workshops, and within the DevRel workshops, there is this Add Tech with Your workshop. So you have all the code is here. You can just take it and try it yourself. And yeah, and let me know if you have any questions.